Curious Minds.
Welcome back to Curious Minds. Today, we're going to talk about the physics of sound. Sound is all around us, and understanding its properties and behavior is essential to appreciate and control it. In this video, we'll explore the science behind sound, including its properties, how it travels, and how it interacts with different media. We'll also look at how sound is produced and measured, and how it is used in various applications, such as music, communication, and medical diagnostics. Sound is a type of wave, which means it has properties that are shared by other types of waves, such as light waves and water waves. The two most important properties of sound waves are frequency and amplitude. Frequency refers to the number of waves that pass through a given point in 1 second and is measured in hertz. The higher the frequency, the higher the pitch of the sound. For example, a high-pitched whistle has a higher frequency than a low-pitched drum. Amplitude refers to the maximum displacement of a wave from its equilibrium position, and it is related to the volume or loudness of the sound. The higher the amplitude, the louder the sound. Sound waves with higher amplitudes have more energy and can travel farther, but they can also cause damage to the eardrum if they are too loud. Sound waves travel through a medium, which can be a solid, liquid, or gas. In a solid, sound waves travel fastest because the particles are closely packed and can transmit the vibrations more efficiently. In a gas, sound waves travel slower because the particles are farther apart and require more time to transfer the energy. When a sound wave travels through a medium, it causes the particles to vibrate, which creates a disturbance that propagates through the medium. The wave can be described as a series of compressions and rarefactions, where the compressions are regions of high pressure and high density, and the rarefactions are regions of low pressure and low density. As the wave moves through the medium, it creates a pattern of alternating high and low pressure regions, which our ears can detect as sound. The behavior of sound waves depends on the properties of the medium through which they travel. When sound waves encounter a boundary between two mediums, such as air and water or air and a solid, they can be reflected, absorbed, or transmitted, depending on the properties of the medium and the angle of incidence. Reflection occurs when a sound wave encounters a boundary and bounces back in the opposite direction. This is what happens when you shout in a canyon and you hear the echo of your voice. Reflection is also what allows us to hear sounds from distant sources, such as a musician playing in a concert hall. Absorption occurs when a sound wave encounters a medium and some of its energy is absorbed, causing the wave to lose amplitude and eventually dissipate. Absorption is what makes rooms sound dead when there are no furnishings to reflect the sound. Transmission occurs when a sound wave encounters a boundary and passes through it into the next medium. The amount of transmission depends on the properties of the media and the angle of incidence. For example, when a sound wave passes through a thin material such as a window, the transmission is almost complete and the sound is only slightly attenuated. Sound is produced by vibrating objects, which create pressure waves that propagate through the air. In musical instruments, such as a guitar or a trumpet, the sound is produced by the vibration of a string or a column of air, respectively. In our vocal cords, the sound is produced by the vibration of the folds of tissue in our larynx, which creates pressure waves that are modified by our mouth, tongue, and lips to produce speech. Sound can be measured in different ways, depending on the application. The most common unit of measurement for sound is the decibel, which is a logarithmic scale that compares the intensity of a sound wave to a reference level. The human ear can detect sounds in a wide range of intensities, from the sound of a pin dropping to the sound of a jet engine taking off. The threshold of hearing is defined as 0 decibels, and the threshold of pain is around 120 decibels. Sounds that are too loud can cause hearing loss or other health problems, so it is important to protect your ears when exposed to loud sounds for extended periods. Sound is used in many different applications, from music to communication to medical diagnostics. In music, sound is used to create a wide variety of musical instruments and to produce recorded music. In communication, sound is used to convey information through speech, telephones, and other devices. In medical diagnostics, sound is used to produce images of the body, such as ultrasound images of the fetus or the heart. In conclusion, the physics of sound is a fascinating topic that has many practical applications in our daily lives. By understanding the properties of sound, how it travels, and how it interacts with different mediums, we can appreciate and control sound better. From the music we listen to the conversations we have, to the medical procedures we undergo, sound plays a crucial role in many aspects of our lives. We hope this video has helped you understand the science behind sound and appreciate its many uses. Thank you for watching. If you enjoyed this video, please like and subscribe. And don't forget to stay curious